Hi everybody, you're watching Video Notes 2.1, Functions and Relations. I think you've heard of this definition last year, but we're going to repeat it and make sure you know it real well for the algebra test at the end of the year. A function is clearly defined as a rule that converts an input into at most one output. And I always say what you see here highlighted in yellow. Every x value has only one y value. Every x has only one y. These rules often come in the form of equations, graphs, tables, and verbal descriptions. And you'll also see, if you look down the page here, we can see mapping diagrams as well. So let's go back up to exercise 1. These are done for you, so you don't really have to write. You just might want to point out a few things that I've pointed out. So exercise 1, consider the relation to the right. Is this relation a function? And you have to explain, which means you need words. So I'm looking at all these points that are scattered around. I labeled them with their ordered pairs. So here's the origin, labeled all the pairs. And I'm thinking that this is not a function because when I look at the x value of 2, like right here on the graph, I could go up to this point, which is 2, 3, or I could go down to this point, 2, negative 1. So the x value of 2 has two y values. If it was a function, each x has only one y. This x value hits at two different y values. Part B, write out each of the points in set notation. So I took all my ordered pairs and I listed them as a set of points. I put squirrely brackets, I call them, around it. And then it says what 2 points indicate that this relation is not a function. So they're highlighted in green. X equals 2 has two different y values. It's not a function because these 2 points, the input value of 2 has two outputs, negative 1 and 3. If it were a function, again, each x would have only one y. Write this as a mapping diagram, so it's the same function. In this circle, I have all of the x values that were used by the points. In this circle, I have all the y values. And then I drew a line from each x value to its corresponding y value. Since 2, you can see the red lines here, going from 2, is being mapped to negative 1 and 3, we can see that it's not a function. 2 has two outputs. Each x has to have only one y. It has two y values. Exercise 2. So this is a different function. It says explain why this is a function. Why or why not? I said this relation is a function because each x value has only one y value. So if you look at these x values, they only appear once. There's no repeated x values. So clearly each one has only one x value or one y value. If I were to list, say, 3 again and put 8 over here, then 3 would have two y values and it would not be a function. Turn the page, and these are some questions that are not answered yet. So exercise 3. Marcel claims that the graph below represents a function. State whether he is correct and justify your answer. Well, I'm moving along at each of these points, even the ones in between, and I'm seeing that each x value only has one y value. If you go up to the graph and over, it only has one y value. However, when I get to 2, I'm noticing that at x equals 2, I have a y value at 3 and a y value at negative 1. This is not a function. An x value has two y values. So each x does not have only one y. Exercise 4. Function rules do not always have to be numerical. They simply have to return a single output for the given input. The table below gives a rule that takes an input, which is a neighborhood child, and gives an output, the month they were born. Is this rule a function? And you have to explain in words. We're looking down the child list, which would be my X or input, and looking at the birth months, which would be like Y. I see that Madison, this child named Madison, has a birth month in September and June. Don't know how he was born twice, or she was born twice, but it appears here that she did get born twice. Okay, so is this rule a function? I'm going to say no, and the reason is Madison has 2 birth months. Each input does not have one and only one output. It says find all inputs that give an output of May. All right, let's look at the table. I see May here and I see May here. So Zeke and Nico have May birth months. Then it says, why does this not violate the definition of a function? Well, it's okay as long as Zeke only has one output. I don't see him having another birth month. And Nico only has one output. It's okay to have the same output. So each is spelled like that, E-A-C-H. Each input, Zeke, Nico, has only one output. So Zeke just has May, and Nico just has May. So it fits the definition of a function. And finally, exercise 5. A function is shown in the table below. Tells me it's a function. If included in the table, which ordered pair, this one or this one, -4, 1, x, y, or 1, -4, x, y, would result in a relation that is no longer a function. So I added on to the table, and I thought if I put -4, 1 in the table, then -4 would have 2 different outputs, and it would no longer be a function. If I put 1, -4, 1 is not already in here, so that would remain a function. So the answer is -4, 1, and the reason, so that's part of the answer, and the reason is because then -4 would have 2 outputs, and they would be 2 and 1. 2 here, 1 here. So if you have that, then it's no longer a function. All right, thank you for joining me. I tried to keep it short and sweet, 8 minutes and 43 seconds, and I hope you guys understand what we did. The only thing I didn't mention was this thing called the vertical line test. And I just want to say that when you're looking at a function, if the vertical line only hits once, then you know that each x only has one y value. So if you pass the vertical line test, then you are a function. Enjoy.